Hello everyone, welcome to my presentation on news classification using supervised machine learning techniques. The goal of this project is to build models to predict category of news based on short description of news and news headlines. As shown in the figure on the right, the classifier models would take the news headline or short description as input and predict which of the 6 main categories this news belongs to. The ideal model generates an accurate prediction for news, like the headline, "The surprising benefits of daydreaming," would be predicted under category wellness. In order to build this model, I need a news dataset with classified news category for training and testing. The news category dataset is from Kaggle, which contains around 120,000 news from 2012 to 2018 obtained from HuffPost. This dataset has 6 variables: date, news headline, category, URL link, news short description, and author. Only headline, short description, and category are used in this study. In this slide, I will talk about how to extract features from the headline and short description. The general idea is shingling and TF-IDF. The shingling method converts documents into a set of n-grams. 1 gram of the sentence, "The surprising benefits of daydreaming," can be converted into 1 gram set with first gram, "the," second, "surprising," and "benefits of," and "daydreaming." You may notice some of the words are not related with the news content itself, like "of" and "the," and these are called stop words and will be removed in the next step. Besides removing stop words, I also removed numbers and punctuations and kept only word stem to reduce the number of features. After shingling, I split the entire dataset into 5 folds and calculate TF-IDF score of the shingles within each news headline to build a TF-IDF matrix. TF-IDF matrix is shown on the bottom left, with each column representing a shingle and each row representing a news. For column I and news J, the value is the TF-IDF score of shingle I in news J. TF-IDF score is term frequency times inverse document frequency. Feel free to pause here to take a look. Let's move to model design. Even though the decision tree has low cross-validated accuracy score, I would like to show it first because it's simple and easy to interpret, like a glass box model. Decision tree simulates sequential decision process. The feature is evaluated at the root of the tree to determine which branch would be selected. This process is done repeatedly until max depth of the tree is reached or the classification target is met. The slide shows 2 binary decision tree and train and cross-validated accuracy score by max tree depth. In wellness binary tree with maximal depth equals to 4, the TF-IDF score of health is evaluated at the root. If it's higher than 0.25, then it's wellness news. Otherwise, check TF-IDF score of Trump. If it's higher than 0.055, then it's not wellness news. After then, check the score of sleep and cancer until maximal tree depth is reached. In politics binary tree with maximal depth of the tree equals to 3, the TF-IDF score of Trump is evaluated at the root. If it's higher than 0.055, then it's politics news. Otherwise, check Clinton. If it's higher than 0.24, then it's politics news. After then, score of Senate is checked. The accuracy score of the decision tree at maximum depth equals to 15 is around 0.85 for both trees, which is not ideal but still much higher than picking a class randomly. The second model that I use is logistic regression model for binary classification and multinomial logistic regression for multi-class classification. After converting news headlines to TF-IDF matrix, the dimension of the data becomes over 9,000. The most crucial step of this project is to reduce dimensionality. In this study, I used logistic regression model with lasso to predict two classes with reduced dimensionality by shrinking most of the coefficients towards zero. Shrinkage is done by penalizing the regression model with the penalty term L1 norm, which is the sum of the absolute coefficients. The figures on the left shows how the numbers of non-zero coefficients change with different L1 norm, and the figures in the middle shows how I observe cross-validation to select the optimal lambda value for the lasso. So far, the model works well for binary classification as shown in the ROC curve on the right of this slide. I'll compare performance of the multi-class classification models at the end. The last algorithm that I apply is support vector machine with linear discriminant analysis, LDA. As you may remember from the previous slides, the data is in high dimension with over 9,000 features. I need to reduce the dimensionality of the data before applying SVM. LDA is used to find projection matrix directions that maximize the separation among classes. For C-class classification, LDA produces at most C-1 feature projections. There are 6 main categories in this data, so I have 5 feature projections. Let's call them LD1 to LD5. I include 2 scatter plots from LDA to show the separation of the projections onto the plane formed by 2 of the projecting vectors. After LDA, I apply support vector machine to find the optimal boundary between classes. In this study, the radial basis kernel function is used. In its simplest type, SVM doesn't support multi-class classification, so I would like to show 2 graphs on binary classification first. In the plot on the bottom left, the green points are politics news and the black points are the ones that are not. The other graph that has orange points as wellness news and the black points are the ones that are not wellness news. The boundary of this light gray area is the optimal boundary that differentiates between 2 classes found in training dataset using SVM. Then I move from binary classification to multi-class classification. As we learn in class, there are 2 ways to classify data points from the M classes dataset, one-to-rest approach and one-to-one approach. Due to the limit on time, I would skip this. R has some existing packages that do this automatically for us. On the right, you can find the trained SVM classifier using the trained data and its projection onto the plane formed by LD1 and LD2. In the last slide, let's quickly compare the accuracy score with different inputs and models. Accuracy score is the number of correct predictions divided by total number of predictions. The null model, which predicts using the largest class, has an accuracy score of 0.245. According to the cross-validation results, when projecting using the headline and short description, support vector machine and multinomial logistic regression outperform decision tree in this data. Both SVM and MLR have accuracy score over 0.6 with the headline and near 0.6 with the short description, while decision tree has an accuracy score of 0.38 when predicting with the headline and 0.26 when predicting with the short description. Decision tree doesn't outperform other models in predicting news category, mainly because it used a greedy approach like forward subset selection and is very sensitive to small perturbation in data, which can be improved by random forest bagging or boosting. As you can see from the results in this slide, the other conclusion that we can get is that we can predict news category more accurately using headlines than short descriptions. Okay, That's the end of this presentation. Thank you for watching this video.